For 100 years, one resource ran the world. Oil moved the cars. Oil moved the planes. Oil moved the ships that carried nations to war and back. It turned deserts into kingdoms and factories into empires. Whoever controlled oil controlled growth itself. That story is not over. But a new infrastructure is quietly becoming even more strategic than oil ever was. It does not make headlines the way a war over a pipeline does. It does not have the drama of an oil embargo, but it is already reshaping who wins the next century of industry, technology, and power. That infrastructure is the power grid. This is not a story about oil disappearing. Oil still moves the world in massive ways. This is a story about what comes next, about the invisible network of wires, transformers, and substations that is becoming the new backbone of the global economy. And once you understand why, you will never look at a power line the same way again. Let's start with why oil became so important in the first place. At the start of the 20th century, oil was just one energy source among several. Coal still powered much of heavy industry, but oil had one advantage nothing else could match. It was dense, portable, and easy to move across borders and oceans. That combination made it the perfect fuel for a world that was starting to move faster than ever before. Cars needed oil. Airplanes needed oil. Naval fleets needed oil to project power across entire oceans. By the middle of the century, oil was not just a commodity, it was a strategic weapon. Nations went to war partly to secure it. Empires rose because they controlled it. Economies collapsed when they lost access to it. Oil became the single resource that decided which countries could industrialize, which militaries could move fast, and which economies could grow without limits. For most of the 20th century, if you wanted to understand global power, you followed the oil. But somewhere in the last 2 decades, a second infrastructure started rising quietly behind the scenes. And in the last few years, it has started accelerating in a way that almost mirrors the early rise of oil itself. That infrastructure is electricity. Not electricity the way your grandparents thought of it, simple lights and appliances. Electricity as the operating system for an entirely new kind of economy. Here is the shift most people have not noticed yet. Artificial intelligence does not run on gasoline. It runs on electricity, and it runs on an enormous amount of it. Every time a data center trains a large language model or processes billions of search queries, it is burning through power at an industrial scale that barely existed a decade ago. The International Energy Agency has been tracking this shift closely, and its research points to something remarkable. Data centers and artificial intelligence workloads are becoming one of the fastest growing sources of new electricity demand on the planet, not in some distant future, right now and accelerating through the rest of this decade. Think about what that actually means. Every chatbot response, every AI image, every automated system running in the background of a modern business, all of it traces back to a power plant somewhere and a grid that has to deliver that power reliably, instantly, and at massive scale. And artificial intelligence is only one piece of the puzzle. Electric vehicles are multiplying on roads around the world, and every single one of them needs to be charged from the same grid that already struggles to keep up with air conditioners on a hot summer day. Robotics and industrial automation are expanding across factories, and machines do not run on diesel the way old assembly lines did. They run on electricity, continuously, precisely, and in growing numbers. Add in battery manufacturing, smart factories, electrified heating and cooling, and entire industries switching away from fossil fuels toward electrified processes, and you start to see the real picture. The world is not just adding a few more electrical devices. It is rebuilding its entire industrial foundation around electricity as the primary energy currency. This is where the story turns from technology to geopolitics. Because generating more electricity is only half the problem. The real challenge, the one almost nobody outside the energy industry talks about, is getting that electricity to where it is needed, when it is needed, without the system collapsing under the pressure. This is the grid bottleneck, and it is becoming one of the most important economic choke points of our time. You can build a massive new solar farm or a new data center campus in a matter of months, but building the transmission lines, substations, and transformers needed to actually move and manage that power can take years, sometimes over a decade, because of permitting, materials, and sheer engineering complexity. The energy exists, the demand exists, but the pipes to move it, in this case wires and transformers, are lagging dangerously behind. This is exactly why governments around the world have started treating grid infrastructure as a national security priority, not just a utility upgrade. A major 2025 global infrastructure survey conducted by Siemens, spanning 19 countries, found something something striking. Resilient energy supply has become the top priority for government surveyed, ahead of almost every other infrastructure concern. Power grids were identified as the central system for managing the collision of renewable energy, electric vehicle demand, and rising geopolitical risk all at once. Read that again. Not oil reserves, not military hardware alone. The power grid itself is now considered the central pressure point of national resilience. That same research found that 76% of energy sector respondents plan to increase investment in data integration for their grids. 73% say they are already using artificial intelligence to help decarbonize their operations. 68% believe autonomous systems inside power grids will become crucial to keeping the lights on in the coming years. In other words, the grid itself is becoming intelligent, automated, and treated with the same strategic seriousness that nations once reserved for oil pipelines and shipping lanes. So who is actually building this new infrastructure? Because behind every strategic shift in history, there have always been companies positioned to capture it. On the hardware and engineering side, a small group of industrial giants sits at the center of the transformation. Siemens, GE Vernova, Hitachi Energy, ABB, Schneider Electric, and Eaton are the companies actually manufacturing the transformers, switchgear, transmission equipment, and digital control systems that make modern grids possible. These are not flashy consumer brands. Most people have never heard of half of them. But without their equipment, none of the electrified future works. They are the quiet architects of the entire system. On the demand side, NVIDIA sits in an unusual position. It does not build power lines, but its chips are driving so much of the artificial intelligence boom that its growth is directly tied to how much new electricity demand data centers require. Every leap forward in AI computing translates into another leap in electricity consumption somewhere on the grid. Then there is the battery and storage layer of this new economy. Tesla Energy, CATL, and BYD are not just building electric vehicles anymore. They are building the storage systems that allow grids to absorb extra solar and wind power during the day and release it during periods of high demand. As more renewable energy comes online, this storage layer becomes just as important as the generation itself, because renewable power is not always available exactly when it is needed. Storage is what smooths that gap out. Put all of these companies together, the grid hardware makers, the chip designers, and the battery manufacturers, and you get a rough map of who is positioned to benefit from one of the largest infrastructure build-outs in modern history. Now here is where the story becomes genuinely geopolitical. Oil was strategic partly because it could be shipped, stored, and controlled across borders. A country without oil reserves could still buy oil from somewhere else, load it onto a tanker, and use it anywhere in the world. Electricity does not work that way. Electricity is mostly local. It has to be generated close to where it is used, and it depends on physical infrastructure that cannot simply be shipped in from another continent overnight. That local nature does not make electricity less strategic. If anything, it makes the physical grid, the transformers, the transmission lines, the control systems even more important, because a country cannot simply outsource its way out of a weak grid the way it can outsource its way out of a lack of oil reserves. You either have the infrastructure or you do not. This is why grid resilience has quietly become one of the most important national security conversations happening inside governments right now. A country with abundant energy but a fragile, outdated grid cannot actually deliver that energy where it matters most, to factories, to data centers, to hospitals, to military installations. The grid is the difference between having power and being able to use it. And this challenge is not isolated to one country, it is a global race. Nations that modernize their grids fastest will be the ones capable of hosting the next generation of data centers, the next wave of advanced manufacturing, and the next stage of electrified transportation. Nations that fall behind on grid modernization risk becoming energy rich but power poor, unable to move electricity fast enough to compete industrially. So here is the question worth sitting with for a moment. If artificial intelligence, electric vehicles, robotics, and industrial automation all depend on one shared resource, reliable, abundant electricity delivered through a modern grid, then which nations and which companies actually have the infrastructure in place to support that future right now? And which ones are still trying to catch up? That question is not rhetorical. It is playing out in boardrooms, government energy departments, and infrastructure budgets around the world at this very moment. Let's connect the dots one more time, because this is the part most people miss. Artificial intelligence needs electricity. Electric vehicles need electricity. Battery factories need electricity. Robotics and automated manufacturing need electricity. Every single pillar of the next industrial era runs through the exact same bottleneck. Not chips, not software, not even raw energy generation alone. The actual physical grid that carries electricity from where it is made to where it is needed. This is why the International Energy Agency, Siemens, Deloitte, and other major research organizations have all converged on the same underlying conclusion in recent reporting. The electricity system is no longer just a utility sitting quietly in the background of modern life. It is becoming the operating infrastructure of the entire technological economy. None of this means oil disappears. Oil still powers massive parts of transportation, shipping, and industry, and it will for a long time. This is not a story about one resource replacing another. It is a story about a second, equally strategic infrastructure rising alongside it. One built not from barrels and pipelines, but from wires, transformers, and substations. Oil built the economic engine of the 20th century. It powered mobility, it powered war, and it powered global trade on a scale no previous resource ever had. The power grid is building the economic engine of the 21st century. It is powering artificial intelligence, it is powering the electrification of transportation, and it is powering the automation of entire industries, all at the same time. And this transformation is not a prediction about some distant future. It is happening right now, in the investment decisions being made by governments, in the earnings reports of the companies building this infrastructure, and in the research being published by organizations tracking energy demand month by month. The next great infrastructure race of the modern era is not about who controls the most oil. It is about who can generate, transmit, store, and deliver electricity fast enough to power everything else. And that race has already begun. This shift touches everyone, not just industry executives and policymakers. Every car in every driveway, every factory in every town, every data center quietly running in the background of daily life. All of it depends on the same invisible network humming behind the walls of every building on the planet. The 20th century was built on what came out of the ground. The 21st century is being built on what runs through the wires. And this transformation is only just beginning. If you want to stay ahead of what is coming next in the industry, in energy, and in the technology reshaping the world's garages and power grids alike, join us here at Driven to Distraction.